However, by having these experiences earlier on, it can reinforce that and help them understand why they're learning all of the concepts that they're learning as they go through, and then it helps synthesize it together. So that's really what Standard 5 is all about. So with Standard 5 now covered, we need to now ask, what workspaces do we need in order to be able to implement these types of projects? And so that's what I now want to move into, is looking at what type of workspaces do we need in order to have a CDIO program. So this is an example CDIO workspace. It's basically a sheet of white paper, and you can do whatever you want in it. You can put different things in there. But at a minimum, if you look at these workspaces at universities across the world and CDIO collaborators, typically what they will have is a concept forum. That is space where you do conceiving. You come up with the ideas, students work in teams. You will have a design center where the students then move on and they start doing things on the computer. They might be doing some very basic modeling. They might start doing CAD, computer-aided design, things like that. Then you would have an implementation lab. That is a space where they actually realize their design and build it. And then you would have an operations center where the students are able to test. And the operations center will change depending upon the nature of the project. Like we saw at KTH, their operations center was a lake. And I would assume before they went there, it's probably a swimming pool. Is that correct, Christina? It was a swimming pool. Where we saw the pictures, I thought it was a lake. Okay, so they did go to a swimming pool before going to the lake. Okay, and so operations center, it's going to vary depending on the project. Formula SAE that we saw earlier, they would need a racetrack. And we do have a Formula SAE team in Calgary. And one of our biggest challenges is that the snow doesn't melt until April. And the competition is in June. And I mean, that's a bit of a stretch. Sometimes the snow is gone by March. But they don't really have any place to go testing until right near the end. And that makes it a little bit of a challenge. And so anyways, Operations Center, that will depend upon the project. What else do you need within this workspace? Well, what is going on in that workspace is students are getting to know one another. Communications, teamwork skills are evolving. So they need places to network. They need social space in order to unwind a little bit as they're working on a project. You might want to sit and have a coffee or a Coke or eat some potato chips. And personal communications are going. So you want to knit that into the workspace as well. Another thing that you need, learning resources. And so there are books that they would potentially need beyond what they can find on the internet, although that's becoming lesser and lesser as time goes on. But learning resources nonetheless, they would need information. Storage. Storage is critically important for CDIO workspace or any of this project-based learning workspace because the project varies from year to year. Some years the projects are small. Other years you might have very, very large projects. So how do you store those when the students aren't all in the lab at the same time? So storage capacity and the ability to store things varies, but that is an important aspect. And finally, exhibits. One thing that is quite good for students is to walk into one of these laboratories and see examples of success cases that are surrounding the laboratory space, where they get an idea as to what students have done in previous years, and that will motivate them then to achieve at the same level. And so that's what we refer to by exhibits. And so what we're going to do is we're going to walk through the four main components of CDIO workspace. And this is conceive space. And here we have an image taken at MIT. That's their conceive space on the right in AeroAstro. But essentially what it is, it's a table with chairs and maybe marker boards, things like that, where students can jot down ideas. But you typically want it to be largely a technology-free zone, although that's a little difficult to do sometimes now. But you don't want students jumping to Google before they even think about what it is they're trying to solve. And so that's why you want to have it a little bit on the technology-free side. Students now that we teach them CAD and all these other software packages, which are really great, but the problem is that their natural instinct sometimes is to jump to that before even doing a sketch. And so you want them to do the technology-free part. That's the conceive space. The next space is the modeling space or the design space. And here I've taken a picture from the D School at Stanford. And what you can see here is a team of students clustered around, and they have multiple monitors and the ability to link in their laptops, which is really quite important because this is the point where they're going to be doing CAD modeling. Somebody might be doing a simulation in MATLAB. Somebody else might be doing something in Excel. So different team members can contribute, and you want them to be able to fuse those ideas together and communicate effectively. And the dual monitor system is really highly valuable for being able to achieve that. The system that they have at Stanford, Steelcase, they test for Steelcase, 3M, and consequently, I'm sure they get a really good deal on this, but I priced these systems out and they were a little bit out of the league of what I could look at. But they're beautiful, beautiful systems that are built by Steelcase. Implement space. So this is the space where after students have their design, they go and they build something. And so it could be as dirty as a workshop, as we have a picture up here taken at Calgary. We have a lab where students go in and they learn how to use the milling machine and the lathe. So if they're doing metal work, they could go back in there. We also have CNC machines. They would have access to those. But you can see with the build space, it tends to, you want to have it close to the milling machines. This is a picture from Shantou, China, with the course that I teach there. But basically large tables where they can assemble their designs in close proximity to the workspaces where they would be using lathes, milling machines, soldering irons, whatever it might be, printed circuit board equipment, breadboards, things that will support the project that the students are working on. And I also show pictures down here in the lower right of 3D printers, which are evolving and becoming better and better and cheaper. And I'm sure you guys here at Taylor's probably have, many, many different 3D printers that the students have access to. This is one, the Cubify, that I particularly like. It's a little on the expensive side in terms of getting the build material, because it comes in an enclosure, and you're paying about 3 times the price of if you just buy the roll of the material, like the ABS. However, what is good is it's very easy to use. It has an LCD interface on the front. You can even do Wi-Fi transfer of your files to it, or you plug in with a USB. So that's the Cubify, and then this is the Cubify Trio. Before coming, I ordered a number of these for our lab in Calgary. And the build volume here is 5.5 inches by 5.5 by 5.5. This build volume, I believe, is 12 by 12 by 12. The resolution is good. It's not as good as what you might get with a very large industrial system like a Titan by Stratasys or anything like that. But still, for the cost, I think I was paying around $3,500 US for one of those. That's really cheap when you compare it to what the cost of the industrial machines were even 5-10 years ago. So that's coming along, and it's actually starting to displace some of this manufacturing, especially when students are doing prototypes that don't need to have the strength. If they're just doing an idea, getting a concept, 3D printing is a wonderful way for them to do that. And then finally, operate space. This is where the students go in and they're doing testing. And what we have here is an image. Again, it's with the program that I teach in China, where the students build a wind turbine. And so this is more of an implement to operate project. And they do a little bit of design, but they build the generator, they build a wind turbine, but they go into the wind tunnel and they do testing. And they're given a half-hour block, and they love it. Actually, this particular group here, I didn't get it. I wish I had a video, because this girl, she was jumping up and down. She was so excited to be in the wind tunnel and collecting data. And typically, our laboratories that we have that do not involve where the students are building their projects, the first thing students ask is, what do I need to collect? What do I have to write down? And when do I get to leave? And so to see examples here where students, you have to kick them out of the lab because they love it so much, I mean, that kind of shows the power of this type of approach for student learning. They become heavily engaged with what's going on. But operate space, again, it's going to vary and depend upon the nature of the project that the students are working on. So these are some more images, a combination of images collected from both MIT as well as KTH. And what you can see on the upper left, we have reinforcing disciplinary knowledge. So that might be a solid mechanics lab where you're testing a beam, for example. And you can use this workspace to demonstrate things that you would normally demonstrate in a course. Community building. Again, this is from MIT Astro Aero. And so this is an upper level where they kind of have a student lounge study area. Tables that can move around, nice comfortable chairs. The students start arriving there early in the morning and they stay there till late at night, and that's where they will do their teamwork. But you'll notice right here there's a stairwell, and that stairwell goes down to a lower level where they have all of the tables, and each team would have their own table, and that's where they're building their project. So you want to have social space in close proximity to your workspace. Knowledge discovery, that would be on the operational side where the students can then go and test their project. And then this is a picture from KTH where what they did, and I'll come back to this point later in the talk this morning, but they took basically a classroom and without a lot of money investment were able to convert it into a build space for the students doing projects. And this is critical. Sometimes people will say, well, I don't have workspace to do that, so I can't start. That's not always true. You can. You just have to retask what you currently have and apply it for the particular application that you may have. And once you do that, you gain experience and then you build. And you then gain momentum. And I'll talk a little bit more about that as we move on. These are pictures of CDIO workspaces that I've collected over the years. It's just a small handful of them. But at the top, what we see is Arizona State. And this was where they were doing a very interesting approach to education, where the students were basically going from project to project, and the course material would be infused in as the project was progressing. So it's more of a heavily project-based learning approach as opposed to courses with the projects then stitching in. But nonetheless, you can see the workspace that they have here. What they have are students, and then this was all taken at the same time. Those are pillars, and I've tried to stitch the photos together so that you get an idea as to what the room actually looks like. But you can see there's one group of students over here presenting, and the instructors are there critiquing, assessing them. And then there's another group of students over here, and there are a couple of CDIO people there watching what's going on. And I think, Paul, are you in the room? Because I think that's you. Lower left, this is University of Liverpool. They have a beautiful workspace there, and you can see they spent a lot of time thinking about the design of these tables. And these are basically the workbenches where the students come and they work. But they went to the level of detail of things like figuring out where are students going to put their book bags. How can we have it so that we can connect these together or separate them apart? Highly multifunctional. That's really one of the things that you want to strive for, to be able to move them around. So all these tables are on wheels, and there's Matt. He's in that photo. And then Peter Goodhue. He was a long time involved with CDIO, and he's on the left in that photo. And then another picture here. This is from University of Colorado Boulder, their integrated teaching learning laboratory, and that's their lab plaza. And they take a very interesting approach to the lab plaza, where what they have done is they've co-located all of the laboratories and all of their different courses into the same physical space. And the labs will book time, come in, they'll use that workbench for a particular lab, and then that lab will end and they'll pull the equipment away, and then another lab will come in. So really a very, very clever approach to use of workspace. I've done the calculations for the laboratories that we have in Calgary, and the utilization rate due to timetabling is not that high for the laboratories. So what they've done here in Colorado is really a very brilliant approach to having a high utilization rate for the space. And then at the end of the day, students are free to come in and work on projects using this workspace. And there are machine shops located very close by. Actually, it's one floor below, where they can go and use lathes, milling machines, 3D printers, things like that. So they can work on their projects in this space as well. So what types of things do you need to think about as you look or start a plan for building a CDIO workspace? The things that you need to think about, and I've kind of alluded to that in some of the pictures that I've shown you, is flexibility. You don't necessarily know what you're going to be using that workspace for, given projects will change from year to year. So flexibility is critically important. You want to be able to move the tables around, reconfigure them. You can use it for many, many different purposes. Use the workspace, that is. Connectivity. I was giving you the images at MIT where you saw the social space co-located directly above where the students are building their projects. You want to have things closely located so that the students will, if they have an idea, oh, you know, I need to do that, they'll run right to the workshop and do it and not procrastinate and think, well, I'll do it some other day, because you know it's a little further away. So connectivity is very important. Safety is critically important as well. I've seen many different types of approaches to safety. Anything from having a technician there at all times, which makes a lot of sense. That's especially if you have dangerous equipment like a lathe or a milling machine. To things where you could potentially lock out that equipment. So what you might do is have a circuit breaker that would knock out power to all of the heavy machinery, but leave students having access to things like glue guns and sanders and things like that they won't do that much damage if they're using. But safety is critically important. You also have to have training so that the students can get and gain, the experience and know what they're doing when they're using that equipment. Hours of operation have seen everything that varies from, just a few hours in the afternoon. Stanford had a very nice design, 8 a.m. to I think it was 10 p.m. with their product realization laboratory. And so they keep that open for long periods of time, which is really great. Staffing, I mentioned safety or having people there help the students as they come in, showing them how to use equipment. Security, the 3D printers, although they're cheap, they're still a couple $1,000 and you can pick them up and walk out with them. And so you have to be a little careful about things like that, making sure that you have security. Scheduling and use, that's all normal things that we have to worry about. Ownership, that's what you want to do is you want to build a culture where the students feel that that's their space and that they can go in there and that they can use it. You don't want it to be just some space that they don't normally use. So ownership would be to have them feel that it is a space that they can go and use. And sometimes it takes time to build that culture. Display devices and areas, we talked about exhibits, storage of equipment, social space, furnishings, what types of couches or chairs are good. Stanford was very interesting for their approach. What they do, they go to IKEA and they buy a couch, not the most expensive couch. They put wheels on it, and when the couch, gets abused, they throw it out and go and buy another couch. So sometimes the people within universities will say, no, we can only go to this vendor, and we can only buy this furniture, and it's going to cost you $5,000 for a couch. Well, you go to IKEA, you can buy that couch for $500. To me, that's the much more intelligent approach to it. Sometimes within universities, we have rules and regulations that prevent things that otherwise would appear kind of logical. Public address areas and systems, so if you have design forums in there or any other type of presentation, exhibits, things like that, you want to be able to have that ability. And then finally, cost. How much is it going to cost? You always have to factor that in. So these are things that you need to think about as you're looking at planning workspace. What I want to now do is move into a bit of a personal experience that I had in terms of strategies for securing new space, new CDIO type space. And so the one thing that I would say, and this kind of echoes back to what KTH was doing, use what you have and do something. Don't just sit around and wait for the dean or somebody else to come in and say, here's space for you to use. You have to use what you currently have, demonstrate success, and then you can build a case to then have more space. So do something. That's the first thing that I would say, and demonstrate success. And then provide motivation for improved new space. So what types of strategies can you do? What I did when I became a department head back in November 2005, I did a space audit. I looked at all the space I had. I went and I found space standards that they said for this many students you should have this many square meters. And I built a case showing that I didn't have enough space. I think it was at like 30% of what I should have had. So space audit, that's one thing I would do. Look at student demand. In Calgary, I don't have a problem with student demand, but if you do have a problem with student demand where students don't want your program, then by having really good space that they find interesting can help build student demand. Student attrition, sometimes students drop out, we talked about that. They drop out because they're not interested. Well, this type of space can help secure students to stay in because they understand what it is that engineers actually do. And another thing, industry surveys, I refer to ASME Vision 2030. They have surveyed over 1,000 people from industry, and many of the skills that the students are lacking would be developed in the design implement experiences and the CDIO workspaces that we're talking about here. So here is my personal case at the University of Calgary. That's the University of Calgary campus as it would have looked about 2 weeks ago, or maybe a week ago. On Sunday, we received about 4 inches of snow, so it would be white now if you were there. However, that is my building, and that is the mechanical engineering building, so all of our students are in there. And after doing that space audit, I realized that I needed more space. And so I developed a plan, and this is the footprint of the lower floor, and it's flipped around, I apologize, but this wing is actually right there. That's that part coming out. And I took my plan to the then dean, and I said, I need more space, because these are the numbers. I would like to go and do fundraising, and we can add space. We have project-based learning space in here. Our students need it. It'll be wonderful. So that was my approach. And I went through the detailed space audit, took it to her, and was showing, developing a very compelling argument. Her response was, at the time she was the dean, she's now the president of my university, but she commented, it needs to be more than just for mechanical engineering, Ron. And consequently, that was a bit of a setback, but at the same time it was a good thing because she acknowledged, yeah, we need more space. I like the approach you've taken. Let's do it for the entire School of Engineering. And so what then happened is a detailed space audit was done for the entire school, and they used CDIO ideas embedded throughout that entire proposal development and came up with a plan to go to both industry and government to basically lobby for more space. And last week, we had the announcement from the province that the province is going to be giving us about $142 million to build this new infrastructure, and they've already started digging, and the project is going in. The Canadian dollar, by the way, is pretty much the same as the US dollar. So 142 million is about 142 million US. And we also secured a corporate donor, 7 million to name the space. So overall, after everything's rolled in, it's going to be about a $156 million project that came out of that original push of doing the space audit, saying that we need more space for the students. And so what I have here, this is a video clip that I want to show you. And I've trimmed this. So this is the promotional video that came out from the School of Engineering. And I've trimmed out the parts. It's 4 minutes. I've cut it down to 2. And I've kept the things that I feel are student-type workspace. So let's take a look at that. So it'll be a little jagged because I've done transitions where they shouldn't be. So that's our existing building. My building is across the road, so it's going to be in a new space, but they're going to fill in this kind of open courtyard with I think it's a 5-story structure. So that gives you an idea as to where that original idea of we need more space for mechanical engineering eventually evolved into. And I'm very excited.